How do you turn large security frameworks into controls that auditors, regulators, and engineers can actually use? In this lesson, we'll connect NIST CSF 2.0, ISO 27001, and SOC 2 to the real architecture of digital asset platforms. Up to this point, we've built the issuance stack: platforms, tokens, settlement, custody, and compliance. Now we translate those design choices into security frameworks auditors recognize, including NIST, ISO, and SOC 2. After that, we'll move into threat modeling. Digital asset platforms sit at the intersection of finance, software, custody, and compliance. That combination creates risk that isolated checklists cannot manage well. A security framework turns the moving parts into shared expectations: governance, technical controls, audit evidence, and operational accountability. It helps clients, regulators, and risk teams understand how the platform protects assets, validates smart contracts, secures integrations, and proves readiness for institutional adoption. NIST CSF 2.0 gives blockchain teams a practical operating model, not just a compliance checklist. Govern sets strategy, accountability, and risk appetite. Identify clarifies assets, dependencies, data flows, and threats. Protect and detect turn that understanding into controls and monitoring, including blockchain-specific activity. Respond and recover make sure incidents are handled quickly, communications are coordinated, and services return safely. Together, these functions connect technology, process, people, vendors, and governance into one security system. Govern and identify are where security becomes accountable. Before selecting controls, define who owns each risk, asset, and critical process. For a digital asset platform, the inventory must include smart contracts, wallets, keys, nodes, APIs, token types, vendors, and custody connections. Then map how issuance, onboarding, transfers, settlement, and redemption depend on those components. The main takeaway is ownership. High-impact areas like keys, privileged access, and contract upgrades need named owners and clear control expectations. Once ownership is clear, protect turns governance into prevention. For regulated digital assets, safeguards need to exist at every layer: who can act, what they can approve, how keys are used, how contracts change, and how sensitive data is handled. Least privilege, MFA, segregation of duties, MPC or HSM custody, approval workflows, audits, and secure development all reduce both likelihood and blast radius. The point is to make unauthorized or unsafe actions difficult by design, not just detectable later. Detection in blockchain environments is not one monitoring stream. It is correlation. Traditional signals from APIs, databases, identity systems, cloud logs, nodes, and custody platforms need to be evaluated alongside on-chain behavior, such as transfers, minting, burning, contract upgrades, and role changes. The aim is to turn scattered events into actionable alerts: sanctions hits, key policy violations, unauthorized transfer attempts, abnormal transaction patterns, or infrastructure failures. Strong detection connects security, operations, and compliance before issues become incidents. When an incident occurs, respond and recover turn chaos into a controlled procedure. First, detect and triage what happened: a key compromise, exploit, API breach, outage, or sanctions trigger. Then contain the damage by pausing transfers, freezing transactions, revoking roles, rotating keys, or coordinating with custodians. Recovery means restoring systems from backups, reconciling assets and ledgers, and recovering accounts. Finally, document decisions, notify customers or regulators, and feed lessons back into stronger playbooks. ISO 27001 shifts the focus from individual controls to a management system for running security deliberately. Start by defining the ISMS scope, policies, roles, and governance. Then assess risks and choose treatments that fit the platform's real processes, such as onboarding, issuance, settlement, custody, and reporting. Controls need to connect to how work actually happens. Audits, metrics, corrective actions, and management reviews keep the system improving as threats, technology, and providers change. A useful mental model is that blockchain architecture does not sit outside ISO 27001. Each control domain lands somewhere concrete. Access control governs admin portals, custody consoles, deployment rights, and smart contract roles. Cryptography covers wallet keys, signing rules, HSMs, MPC, encryption, and recovery. Supplier controls extend to custodians, node providers, analytics, KYC, and cloud platforms. Secure development applies to smart contracts, APIs, dependencies, testing, and release approvals. The audit question becomes, what control, where applied, and what evidence proves it? SOC 2 gives institutions a common language for judging whether a digital asset platform is operationally trustworthy. Security asks whether access, changes, monitoring, and incident response are controlled. Availability asks whether the platform, nodes, backups, and continuity plans can support uptime. Confidentiality and privacy protect investor records, KYC files, and transaction data. Processing integrity confirms that issuance, transfers, settlement, reconciliation, and reporting are accurate and restricted as intended. The value is independent attestation, not self-assurance. In practice, most organizations do not need 3 separate control programs just because they report against 3 frameworks. A stronger model is one unified control library with clear IDs, objectives, owners, implementation details, and evidence expectations. Each control can then map to NIST CSF functions, ISO clauses and annex controls, and SOC 2 criteria. This keeps access management, logging, encryption, incident response, vendor security, and change management consistent while preserving traceability from business risk to audit evidence. Controls become audit-ready when evidence is collected as part of normal operations, not assembled in a rush later. For each control, keep proof of design, approval, operation, and review. That includes governance records, technical logs and scans, vendor due diligence, contracts, incident records, and training artifacts. Store evidence in a controlled repository with clear owners, versions, retention rules, access restrictions, and traceability. The audit mindset is simple. If you cannot produce reliable evidence, the control is hard to trust. Continuous compliance turns control mapping into an operating rhythm. For a tokenized bond platform, every control has an owner, and every piece of evidence has a source. Cloud tools, CI/CD, SIEM, ticketing, and custody systems can refresh evidence automatically. Dashboards then show control health, overdue reviews, risks, incidents, vulnerabilities, and vendor issues. The key is cadence. Monthly control reviews, quarterly risk reviews, audits, and management reporting keep gaps visible and remediation accountable. Taken together, NIST CSF 2.0, ISO 27001, and SOC 2 turn digital asset platform design into an auditable control environment. They support governance, resilience, and institutional assurance. Next, we move from controls to risk scenarios, using threat modeling across blockchain, custody, cloud, APIs, and smart contracts.